Welcome back, students, to part 2 of support tutorial 6. We're still dealing with the theory of demand. We're focusing on utility, and now we're going to take a look at ordinal analysis of utility, which we introduced you to in the previous part 1 for this tutorial. We're covering now the indifference approach, which is part of chapter 8. In fact, all of chapter 8. You need to study this one in detail. Indifference curves are the basis of what we are looking at here. We use indifference curves to illustrate marginal utility and total utility. Truth be known, it's more total utility than marginal. We analyze marginal utility in the context of the indifference curve, but we don't really see marginal utility on the indifference curve compared to how we were able to see it in those tables that I did in part 1. You must be able to define an indifference curve. It is a curve that shows all the combinations of two products that will provide the consumer with equal levels of satisfaction or utility. We'll get to understand that a little bit now as we look at the utility curve or the indifference curve. And then we need to pay special attention to two components of the theory, students. I find that students frequently mix these two up. The assumptions, please learn them. You'll see them in the textbook, in your notes. You'll have covered them in your lectures and in the properties. One of the key problems that arise in the test for students or in the exam is students mix these two up and then lose valuable marks. Make sure you find a way to mark each of them very clearly, that you are aware these are the assumptions, these are the properties. I'm not going to cover those now. You'll cover them in your lectures. We're going to try and plot an indifference curve so that you can get an idea of what it looks like. Use this information, have a bash at plotting it, see what your curve looks like, and then please make sure that you pay attention to what the indifference curve should and must look like. All right. So you can pause now if you are busy drawing up your axes and preparing to plot. I'm going on to the actual curve now. There you go. There you see it. An indifference curve should be convex. It's downward sloping. Please, it is not a straight line. Make sure you do not draw it as a straight line. It is a convex shaped curve that is convex to the origin. And obviously it shows an inverse relationship between the quantity of the two products on each of the axes. We're going to be looking at this curve in a little bit more detail on the next slide. There you have it. We need to be able to understand when we move from one point on the indifference curve to another. This illustrates some important concepts, two of which I'm covering here. You will also cover some others in your actual lectures, and they are covered in the textbook. But one of the key things here is the rate at which we give up the one product, get more of the other product, and keep our level of satisfaction the same. In other words, we stay on a given utility curve. And this is referred to as the marginal rate of substitution. So for example, if we're moving from point A to point B, so if we move down this curve from point A to point B, we are giving up a certain amount of bread, we are getting a certain amount of meat in order to keep our satisfaction the same. And as I say, this is called the marginal rate of substitution. This changes as we move down along an indifference curve. Now, those of you who have used a little bit of your maths thinking here will perhaps have picked up already that that marginal rate of substitution is in fact the gradient of the indifference curve. So each time we calculate the MRS, we are in fact calculating the gradient of that part of our indifference curve. What you would also notice if we did the calculations here, which you don't need to do for purposes of this course, if you did the calculations here, you would find that your MRS decreases as you move downward along a given indifference curve. However, remember that your level of utility, your total utility at A, at B, at C, at D, and at E remains the same. However, your marginal utility does not remain the same because your marginal utility decreases the more of a good you consume, or it increases the less of a good you consume. So please It is a little bit complex. Just pay attention to it. Make sure you read it through carefully and understand those relationships. The absolute key, though, is the information that appears in front of you here. Can you describe MRS, marginal rate of substitution? Do you understand that it is the gradient of the indifference curve? And then do you remember, or will you be able to write down the equations that represent our marginal rate of substitution? When there is more than one indifference curve, we refer to it as an indifference map. That is one of your properties of indifference curves. What is important to understand at this point is that every single individual has an infinite number of possible utility curves. We could be on any of those utility curves. The question that we now are going to try and answer is what limits us. One of the assumptions that you will learn about indifference curves is that more is always better than less. In other words, a rational consumer wants to maximize satisfaction and therefore will always choose to be on the highest possible indifference curve. So, back to the question, what limits a consumer's consumption? There's two things: the amount of income that we have available and the prices of different goods and services. Kind of what we always do when we're spending. We look at the prices and we look at how much money we're prepared to spend on it. And that gives us an idea of what we can purchase and therefore consume, and therefore our level of satisfaction that is achievable. We need, with this information, the amount of income and the prices in our graphical form, we need to derive what we call a budget line. Let's take a look. We're going to use this information to derive our budget line. The consumer has 260 Rand to spend. He wants to spend, or she wants to spend, on hamburgers and sodas. The question is, what is the maximum number of hamburgers and the maximum number of sodas that this consumer could purchase with this amount of income, and given the prices of these products? We're going to use this information to draw our budget line. Here we go. We have to do this little calculation first. So we'll take our total income divided by the price of hamburgers, and that will tell us the maximum number of hamburgers we can purchase is 4. If we do the same with, and that will be 0 sodas. If we do the same with sodas, that is, we're going to spend all of our income on sodas. We take our total income, we divide it by the price of sodas, and then we discover that we could purchase either 4 hamburgers and no sodas, or 0 hamburgers and 13 sodas. This, folks, gives us the information that we need to actually derive our budget line. We go on to our quantity of hamburgers, we mark our maximum. We go on to our quantity of sodas, we mark our maximum, and then we simply join those 2 points together. That gives us our budget line. Any point on that line will imply that we are spending all of our 260 Rand. We cannot go beyond that because we don't have sufficient income. If we are inside of that line, we are spending less than our total income on our burgers and sodas. So you can almost think of it as our line of affordability, all right? So now the question is, what is the gradient or the slope of this budget line? You can work it out quite simply by looking at delta Q of whatever is on the y-axis divided by delta Q of whatever is on the x-axis. That is the normal way that you would calculate the gradient for a straight line. Once again, this is calling on a little bit of mathematics here, so do be sure that if you are finding it a little bit challenging, it's not economics that's the problem, it's the mathematics, all right? Please once again pay attention to the equation. You need to be able to express the equation. Now I've expressed it in terms of the products that we are using here, but remember, if we did it in generic terms, it would be delta QY over delta QS, which is equal to delta QX, so delta QY over delta QX, which is equal to the price of X, whatever's on the X-axis, divided by the price of whatever is on the Y-axis. Do pay attention to that when you're studying it, so that you don't make any silly errors. The norm in economics, we are getting to some sort of equilibrium position. This is called consumer equilibrium and is completely different to your market equilibrium that you learned way back when. Please be careful of that. Make sure you pay attention to which equilibrium a question is asking you about. We're going to put our indifference curve and our budget line together now. Here they go. We're going to take that budget line and we're going to try and find out where would our consumer be able to maximize his or her satisfaction. And it would be in this graph at point B. And that is where your budget line is tangent to the highest possible indifference curve. At that point, our consumer is able to spend his or her income achieving the highest level of satisfaction that is possible. What is important here as well, folks, is that you're able to see that the gradient of your indifference curve, which is represented by your MRS, is equal to the gradient of the budget line, which is represented by PS over PH. Two important things for you to be able to understand. Folks, what you will now cover in class will be what if. What if the income changes? What if the price of the product changes? We will not be dealing with this in this support tutorial. We assume that we've given you some of the basics now, and you will now be able to go and apply that in your classroom or with your lecturer and be able to work out what happens if. Good luck, folks. See you soon.